We're going to begin our study of roots of real numbers. You may hear the word root used in the terms of square roots, and that's going to be our context right now. Okay. We are going to begin talking about square roots. Every positive number b has two square roots, and they are written as the square root of b and the negative square root of b. Now, the positive square root, which would be this one, is known as the principal square root. You can think of it being in charge, much like Dr. Chapman is in charge of our school. And a positive number has two real square roots. So when we are simplifying a square root as opposed to solving an equation, we only use the principal or the positive root. That's different from solving an equation. So we'll begin with simplifying. Now, the square root of 25, we're only going to use the positive. The square root of 25 is the same as 5 times 5. A square root doesn't have a number in the root, and it's an implied 2 right there. So we will look at this. When you get two numbers under the radical, that means we can take that number out. Now let's look over here at the negative square root of 25. Now the negative square root of 25 means you're going to take the negative of the square root of 25, which is 5. So in your homework, the only time that you will see a negative is when they want you to put a negative in front of your answer. Now, when solving an equation, solving is different from simplifying. You have an equation that you can solve. You're looking for a value for x. Both roots, not just the principal roots, both roots are the solution. Now let's look at this first equation, x squared minus 9. We don't have a middle term with an x in it. And so what we're going to actually do is add 9 to both sides. Well, according to my rule above, the square root, when I solve, is going to be plus or minus the square root of 9. But 9 can be written as 3 and 3, so plus or minus 3. Now let's look at the other one. So I'm going to divide both sides by 5, which gives me x squared is equal to 3, and we're going to take the square root of that as well. So x is going to be positive 3 square rooted, and the negative square root, which you can just use that symbol positive or negative right there. Okay, let's look at the cube root of negative 27. Now, the only way to get a negative number when multiplying three identical numbers is to have a negative number. So, we're going to multiply three negative numbers together. Well, let's start with, I have negative 3 times 9. Well, that's only two negative numbers, but isn't 9 the same as negative 3 times negative 3? It is. So negative 3, negative 3, and negative 3. So that means the cube root of negative 27 is negative 3. You can have a negative cube root, but you cannot have a negative square root. Now let's look at our next example, the cube root of 10 to the 6th. Now, what we were looking for here with the negative 27 over here was 3 of the same, and we're going to be looking for the same with 10 to the 6th. Now, a way to do that is that we want to group this into 3 parts. Now, if I had 6 pieces of pizza and I wanted to group them into 3 equal parts, I would group them by 2's. So 10 squared, 10 squared, and 10 squared. These 10 squared represents 3 different numbers, all multiplied together. And so I've got 3 of them, so what comes out is the 10 squared, and 10 squared is 100. And we did that without the use of a calculator. Okay, let's talk about roots that aren't just squares or cubes. If you have a root, and we're talking about the little number and the crook of the radical, the root's located here, okay? If the root is positive, actually, wrong word. Let's try that again. If the root's even, then the principal root is the nth root of b. The other root is going to be the negative of that. Okay, even like a square root. If the root is odd, like a cube root, then there is exactly 1 root, not 2 roots like with an even. If the root is positive, again, there I go. If the root is even and the number is negative underneath the radical, then there is no real root. Okay, so let's do a couple here. The 4th root of 81. Now the 4th root tells me I need to find 4 numbers that multiply together to make 81. So I have 9 times 9 to start, and then 9 makes 3 times 3, and 3 times 3. So I've got my 4, and that's equal to 3. Now let's look at the next one. The 5th root of 32. And so that means I need to have 5 of the same. So let's start with just 4 times 8. And then we have 2 times 2. And 8 is 3 2's. 2 times 2 times 2. So here's my 5. So this is 2. And then the last one. Let's look at this last one. The square root of negative 25. Well, my rule says that if you have an even root and a negative number, there's no real root, because that would require having 2 numbers that are identical multiplied together to give you a negative, and that's not possible, because 2 positives make a positive and 2 negatives make a positive. So your answer here is no real root. There is a root, it's just not a real number, and you're going to learn about that later.